topmost, hot topic rather, blockchain and cryptocurrency. This you must be knowing, this is the most disruptive technology which is going to span over across India. And you must be knowing that Government of India has introduced central bank digital currency, the digital rupee, which is a blockchain-based official digital currency of India 2022-223. Now, with this thing, today we are going to have this topic. Our speakers I'll formally introduce. Prior to that, I'll invite Mr. Sandeep Kumar Dev, Chairman and Vice President, to give our kind words for this seminar.
Good evening, everybody. And I should not say warm welcome, because now the entire India, I believe, has entered into the hot zone from the winter season. So it's a heartiest welcome. Electronics and Telecommunication Engineering Division organized webinar. Well, the topic chosen by ET Division is always very, very interesting, not only for the electronics and telecommunication engineer, not only to the engineers, but also to the common people. And this time also, it is not an exception. Blockchain and cryptocurrency. What a wonderful topic chosen by our Electronics and Telecommunication Engineering Division. Well, on behalf of West Bengal State Center, I would like to welcome the two panelists, Miss Meena Desai, Joint Director, CDAC Kolkata, and Niladri Shekhar Saha, Joint Director, CDAC Kolkata, our esteemed panelist on this wonderful topic. I would also like to welcome Professor Dr. Girish Srikrishnan Mundara. Well, Girish, welcome to this program as
Thank you, Sandeep.
And Telecommunication Engineering Division Board. We believe that under your guidance and leadership, board will do miracle in this year.
Surely.
I'd also like to welcome Dr. G. Ranganath, my very good friend, the chairman of CATE, the committee which gives the direction to the engineering and technological activity of Institution of Engineers, the most important committee in the IEI. Welcome, Dr. G. Ranganath, to this webinar.
Thank you, sir.
I would also like to welcome our Honorary Secretary, Professor Hitosh Kumar Bomo. Because of his untiring effort, all these programs becoming so much successful. I would also like to welcome Mr. Untitled Chapter, the Joint Convener of West Bengal State Center ET Division, and who is hosting and moderating today's program. Because the today's moderator, Mr. Ramchandra Chakraborty, the convener of the ET Division, is in business tour, and could not be able to, attend this program. But when Chandra Chakraborty is there, I don't think there will be any gap, because he is same type of competency, if not more, than our RCC. It's not reinforced cement concrete, it is Ramchandra Chakraborty. Well, friend, it is my auspicious duty to tell you something about our Institution of Engineers at the beginning of any webinar. You must be knowing that we have already crossed the century mark in the year 2019. So although we are 100 years old, but this old is really gold, because we have the 100 years of technological and engineering expertise with us. And we are now in the second century to help the Indian government to achieve its goal for this century. Today's topic, blockchain and cryptocurrency. Well, I reckon myself as a very, very common man, not as an engineer. So along with others, I am also looking forward to know the basics of this. What is blockchain and what is cryptocurrency? How this crypto will occur in India, how it will operate, what is the future and how does it work? So all these many questions used to come to our mind, but we are not getting any answer. I would thankful to the Electronics Engineering Division to arrange this webinar on this blockchain and cryptocurrency. Once more, welcoming you all. I am handing over to Chanchal Chakraborty to proceed further. Thank you very much. Have a
Thank you,
nice
sir.
evening.
Thank you, sir, for your kind words and just encouraging us for conducting this seminar. Now I'll invite Dr. G.S. Mundada, Chairman, Electronics and Telecommunication Engineering Board, IEI, to put a few words for this seminar.
Thank you. Good evening.
Good evening.
I'm very happy to welcome you all for this technical webinar on blockchain and cryptocurrency organized by West Bengal State Center of IEI under ET Division Board. I am pleased to have Vice President IEI and Chairman of WBSC, Architect Sandeep Ji Dev, Chairman Kate, and my very good friend, Principal Dr. Ranganath Sir, ETDB Council members, and Secretary IEI WBSC and moderator of today's program, Professor Nitosh Kumar Brahma. Our two eminent panelists today, Joint Director CDAC Kolkata, Ms. Meenal Desai and Mr. Niladri Sekhar Saha, and our Director, Assistant Director Technical Engineer Sudip Chakravarti, and all attending this program. The cryptocurrency, as Sandeep sir said, is in much talk about and is spread quite fast now with young generation joining this mission in big numbers. And now Government of India introduced a tax regime for cryptocurrency. Many things of this kind were in recent news, but the technology that made this happen is a blockchain. I hope the deliberation made during this webinar will help us to learn and groom further on this topic as per our own interest and liking. We at ETDB board invite proposals on recent technologies for a webinar to address the issues of concern and help network all the engineers. Requesting all, if you have any topic of such an expertise, kindly get in touch with us and we'll be happy to host the program. I thank you all for sparing your time and encouraging us for this program. Special mention to WBSC because this is the first program we are hosting after this new board has been taken over. Jai Hind. Thank you.
So before Mr. Chanchal Chakraborty give the next invite the next speaker, I would like to tell everybody that because of the wonderful topic, already we have 130 participants in this webinar. So, and I believe that very soon it will cross 150 marks and maybe we can touch 200 today. Thank you very much. Chanchal, please.
Thank you, sir. Thank you, Dr. Mundada, for giving this encouraging talk to us. And now I will invite Dr. R. Ranganath, Chairman Kate, to say a few words for this seminar.
So in absentia, Dr. Thakkaraji, the President of IEI, and Architect Sandeep Dev, who is a good friend of me, the Vice President of IEI and Chairman of West Bengal State Center. And I can say, Girish S. Mundada, beyond his Chairman of ETDB, Electronics Telecommunication Division Board, I can say it's my lovely brother of younger in age, Girish Mundada ji. Two eminent panelists from CDOC, Madam Meena Desai and Niladri Sekhar. And okay, thank you, Niladri Sekhar ji. And C. Chakraborty, who is nicely organized this one as a moderator. And Honorary Secretary of West Bengal State Center, Nitish Kumar Brahma. And headquarter representative from Technical Department, Chakraborty. And good evening to all of you. I am so happy to see and to make a note West Bengal State Center is conducting every month and different programs from different divisions by covering almost all divisions from every quarter or every half yearly. Reports also I have seen. So active participation of the chairman and secretary as well committee members really appreciable. And it is taken advantage of this COVID era by taking webinars without waiting for any presence, making any big burdens for the participants. As they've said, almost as of now, about 136 participants are there. Even if at least 6 of us, all these speakers and etc., 130 participants are there. So 130 curiosity participants are coming means because of important topic what you are going to organize today, blockchain and cryptocurrency. And everyone should understand. And importantly, you've taken 2 panelists or the 2 speakers in the right way from CDAC. Yes, they are the one who can give lot of inputs in this particular domain, where participants are going to feel happy. And of course, this blockchain and cryptocurrency is very, very important. Actually, in the country and in the world, to create a digital money, there's a lot of attempts was there earlier, but it is not successful for a long period. Then Bitcoin was designed to solve this problem by using a specific type of database called as blockchain. Then if you take because I don't want to take much of your time in talking topics when 2 panelists are going to spend their valuable knowledge. But you take a merits, just I'll give few words only. Just if you take a merits of this blockchain technology, which never fails to monitor transaction, that's the first advantage. Then almost all it is impenetrable to a fraud. That means misusing is very, very, very less. There's no possibilities. And also it is very quicker and reliable. So main advantage of this blockchain is that there's no third-party intervention or there's no middleman. That's most important. So that's what when the people want to have a transaction from one end to another end, by this mean they're going to do directly. There's no middleman. It is a faster, it's a quicker. But at the same time, when technology is taken developments, challenges, always will be threat also. So come to the disadvantage here, the people those who are doing this, if they're going to forget the key, then they're going to lose their value. They're going to lose their currency. Of course, for this, one has to be very cautious. So with this small few words of mine, because let us not talk much about this topic by blocking the road for the panelist. Let me congratulate West Bengal State Center who have taken a very important topic. My double congratulations to Chairman of ETDB and my younger brother, as I told you, Dr. Mundadaji. Right topic you brought in the right way, in the right time. Of course, right platform of West Bengal State Center in a dynamic leadership of Vice President of Architect Dave. And let me wish all the participants, please enjoy the panelist. And after enjoying the panelist, if you want any query, of course, moderator is going to pay the pay. How are you going to raise your queries? Either raising your hand or putting your message, whatever the show, raise your questions also. If it is possible, better take their even mail address of the panelist. Afterwards also you can have your doubt clarifications. Today, as Dev was telling, is not only for engineers today, beyond engineers, beyond government, especially business peoples, this blockchain and cryptocurrency is going to be much, much, much useful. Of course, they have to meet the challenges of keeping the key without forgetting and without disclosing to others too. Secrecy has to be maintained. So with this, let me wish every one of you, and let me thank the organizers of West Bengal State Center, Chairman, Under Secretary, and Moderator. And let me thank 2 panelists those who came here from CDAC to share their valuable informations, valuable experience, valuable energy. Let me thank Mundadaji for a wonderful program what you organized and the wonderful platform and most important topic, because I had to attend another online meeting at 6:30. So I had to take leave all of you. All of you should excuse me. With this again, let me thank everyone. Jai Hind and all the best for all of you. Thank
We
you.
are now 106. We are now 163.
Oh, wonderful, wonderful.
We are running very fast to touch the 200 mark.
Yes, sir. Before
So
panelists,
that
let
we'll
me
be having
please
200 participants. Thank
Yes,
you.
sir.
Sancholda, please.
Thank you. All the best.
Thank you,
Thank you.
Thank you, Dr. Ranganath, for setting the context of today's webinar, blockchain and cryptocurrency. Today, this webinar will be presented by Meena Desai, Joint Director, CDAC Kolkata, and Niladri Sekhar Saha, Joint Director, CDAC Kolkata. Now, I am having a responsibility of formally introduce our speakers today. Ms. Meena Desai obtained her BTech in Computer Science and Engineering degree from Calcutta University. Presently, she is working as Joint Director at Center for Development of Advanced Computing, Kolkata. She has been technically involved for past 26 years with 20 various computing projects in varied disciplines, contributing to design, development, implementation of database systems, e-governance projects, digitization along with the repository and retrieval system, web-based technologies, solution, decision support system with data analytics, secured system, software development, and currently pursuing application areas pertaining to the upcoming blockchain technologies. She has anchored around 15 research papers in computing field and is a member for Computer Society of India. He is a recipient of Young IT Professional Award conferred by Computer Society of India in the year 2000. I heartily welcome Ms. Meena Desai for this program. Now her co-speaker will be Mr. Niladri Sekhar Saha. He has obtained his B in Information Technology from Bardhaman University, West Bengal, India. Presently, he is working as Joint Director at Center for Development Advanced Computing, Kolkata. He has been technically involved for past 17 years with various computing projects in varied disciplines, contributing to design, development, implementation of database system, e-governance projects, digitization along with the repository and retrieval system, web-based technology solutions, decision support system with data analytics, secure software development, and currently pursuing application areas pertaining to the upcoming blockchain technologies. He was a member for the development team backed with the certification of recognition from the Manthan Award South Asia 2011 under the category Agriculture and Livelihood for the project Web-Enabled Access for Agricultural Information through PC and mobile service devices. He has worked as a member of the development team of e-auction systems for northeastern states, which acclaimed as finalist in the World Summit Award 2017. This project also backed 6th E-Northeast Award 2016 in the category of e-commerce and business, and Scotch Award 2015 during 41st Scotch Summit in the category of India's best in smart governance. So with all these things, I heartily welcome Ms. Meena Desai and Mr. Niladri Sekhar Saha to deliberate on the today's webinar, blockchain and cryptocurrency. Ms. Desai and Mr. Saha, the platform is all yours. Thank you very much.
Thank you. Thank you very much. Good evening, all of you. Today, we are going to talk about this blockchain and cryptocurrency. This is one of the most disruptive emerging technology that has experienced a very rapid evolution. And you see, in 2022 budget, Finance Ministry has already declared that there will be 30% of tax in the crypto, the digital assets. Most of the digital assets are leaning towards cryptocurrencies. And government has also declared that next financial year, they are going to come up with digital rupees based on the blockchain technology and the other technologies associated with that, so that they can come up with a peer-to-peer payment system. And because of this, today's academia, industry, fintech, everybody are seeking after this particular blockchain technology, which is a very robust and futuristic technology, which gives us a secure data transmission from one peer to peer with no third party involvement. I mean, it is not centrally controlled. Let us go to So as you all know that we are CDAC. CDAC is a powerhouse of emerging revolutionary technologies in ICT, advanced computing, electronics, and information technology and information security. CDAC is one of the major contributors to the development of this unified blockchain framework, which is the part of the national strategy on blockchain towards enabling trusted digital platform. This particular project we have backed from Ministry of Electronics and Information Technology, Government of India. Under this, we are supposed to meet certain objective of the projects. The objective of this particularly unified blockchain framework is to architect an unified blockchain technology stack for rapid and end-to-end secure, scalable, and interoperable blockchain-based application development and deployment for the large-scale adoption of this particular technology, so that the fintech and other industry can avail this particular unified blockchain framework and deploy their own applications. We have to develop unified blockchain framework and applications on distributed infrastructure under this project. And we are working on this. And it is, we are also providing this blockchain as a service infrastructure and blockchain sandbox for the testing of different developing solutions for deployment of applications on blockchain. We have to accelerate the adoption of this blockchain in government, in academia, and the fintech industries, and startup in financial sector. We have to organize capacity building and collaborative programs, and we have to do collaboration with the startups so that some solution can come up. Now, Government of India has already declared that they are going to come up with digital rupees, but they have not specified anything as of now that what will be the mechanism of this digital rupee, whether that will be a cryptocurrency or that will be a legal tender, or what will be the mechanism. I think in the next month, by next month, they are going to frame this particular strategy. Now, in today's presentation, we are going to cover these topics. Blockchain will give a little bit of overview on this blockchain, how this idea of blockchain has been originated. What is the cryptographic security which is associated with blockchain, distributed ledger technology, which is the another name for blockchain given by mostly fintech 3.0, properties of blockchain, and there will be comparison of blockchain with the relational database, some of the use cases of blockchain. We'll talk about cryptocurrency, and then the later part of the presentation will go into the hash algorithm, the encryption part, the most important part of the blockchain technology. the workflow in the blockchain, the mining process, because here any cryptocurrency which is created, that is created by mining process. The blocks are written by mining process, so that will be covered in detail. The structure of block, Merkle tree, proof of work algorithm, smart contracts, blockchain landscape, and pros and cons of blockchain with the conclusion. So now you see a blockchain, this terminology to different sector of people, it has a different meaning. If you take developers in your mind, then developer thinks that it is protocol, some encryption technology, and to securely store some data into a distributed network. That's it for the developer. Developer has this notion in their mind that this is the technology which is said to be blockchain. Now, if you take the business people, the distributed ledger technology, this business people, they think that it is the underlying technology which has brought the explosion of this digital currency, cryptocurrency. They think in that line. The digital asset, the value of asset increases day by day. Today, you must be knowing that the cryptocurrency, that Bitcoin has come down, but in 2021 October, the Bitcoin value was 65,000 USD. So this digital asset, its variability, that is there in the mind of finance and business people. And they know that Bitcoin is implemented based on the blockchain technology. Now, if you think of the technologies, they think that this is the driving force behind the next generation internet. And if you think about the others, like the other part of the society, they think it is radically reshaping the society and the economy. And it is taking us towards a decentralized implementation of any application. There is no third-party centralized organization which will have a control on the applications which are deployed on blockchain. So whatever you think, whichever you think, you look at this blockchain, this captures the imagination of people and fascination of people, because this is a very robust and a profound technology. And I think this is going to have a boom in the future. So by and large, if you look at this blockchain, it is conceptually combination of some encryption and distributed computing. Now, if you think that how this blockchain idea, how this concept has come up, the origin of this blockchain idea, then if we look at way back in 1991, this blockchain technology was first outlined by Stuart Haber and Scott Stornetta. There were two mathematicians who wanted to implement a system where they wanted the time stamping of the document should not be tampered with. Like suppose you are looking at a particular document, it should be ensured to them that this is the version which was originally created. There is no tampering of the document has happened, and this is not the new version. So in order to solve this particular problem, they wrote down this blockchain concept and the technology. But nobody bothered to, look at, because they were way ahead of their time. Their thoughts were way ahead of their time. At this moment today, we think that we require this kind of solution, but they had this in their mind in 1991. And in 1990s, this Nick Szabo, he proposed a digital currency sort of thing, digital payment system, which he named it as a bit gold, but that was never implemented. So nobody looked at this technology and it was silent for many years. In 2008, one pseudonymous man, whose name has been pseudonymously said to be Satoshi Nakamoto, he developed Bitcoin in order to have peer-to-peer payment system, electronic cash payment system. He created this bitcoin.org website on 18th of August 2008, and he devised his first blockchain database. And he registered this particular domain, bitcoin.org. From 2008 to 2010, he used to answer over email whatever queries people wanted to sort out with this Bitcoin. But after 2010, nobody knows what happened to him, whether he's alive or he's a true man behind pseudonymous. It's all anonymous and pseudonymous. And he described his digital cryptocurrency and he named it as a Bitcoin, whose value is around 36,000 USD as on date. Now, why do we need this blockchain? This question comes into our mind because presently, post-COVID period, everything, even from education to payment system, online shopping, everything has gone into digital form. We are fine with this. We get the solution on a click of the button. Why do we need this? People 30 years back, they thought that this will be the requirement in the future. But why do we take it now? Why it was not required earlier? Basically, the need is decentralizing. Because today, we are dependent on bank for our any money handling things, we are dependent on bank. Or say for the healthcare industry, if you see your data are lying with the hospital management. So there is some centralized organization or agency which is controlling the data. And they have full authority to manipulate. They can manipulate with that data also. So transparency is not there and the trust is not there. You see WhatsApp. WhatsApp, we have, very peer-to-peer communication is there, but it's not on the blockchain. So what happens? So many times it has been hacked. Twitter and FB data are not protected. They are used in all nuisance. The US Cambridge Analytica, they have used those social media information for Hillary Clinton's election. So these are the trustless phenomena happening with the data in the present day scenario or present day solutions what we have. Telangana land property also, you see, the land record were tampered with collusion with the authority itself. So trust, transparency, and decentralization, these are the three important aspects which give us the need of the hour. And the solution is that we must go towards something which is non-hackable, some solution which is non-hackable, which is immutable. You cannot alter and change anything. Permanent records are there, and data integrity, protection, and data security. So here comes blockchain. We should move towards blockchain. So currently, the trading of anything happens in the current system where the central agency keeps bookkeeping records, because whatever trade is happening or whatever data is transacted, they are kept in a bookkeeping offline ledger, and ledger is in the custody of the central organization who is controlling those data, like say bank. And for this, we use this bank, which are the trusted third party on which we should not trust upon. Why should we trust upon this third party? And there are approval process to access those data. They cannot access without, but somebody is having that control and they can have access to the data and they can change it at their own will. So, so well, what is the, yeah. So blockchain comes into the picture. Now, what is blockchain? If we give answer to this, as the name indicates, this blockchain is a chain of blocks. These blocks are linked together using cryptography. You will understand how this cryptography chain of blocks will help you to have secure and immutable records. Now, each block contains cryptographic hash of the previous block and a timestamp and the transaction data in the encrypted form. So everything is encrypted, nothing is, legible. This timestamp proves that the particular transaction happened at particular point of time. That is the proof of existence at that point of time when the block was published. And then they are hashed so that nobody can tamper it later on. Now, this iterative process of chain of blocks are added to the chain and it increases its size. This gives the integrity of the previous block, because when you are standing at particular block, if it is not tampered, then all the blocks behind that till the genesis block are completely true and integrity is achieved. This ensures the integrity of the blocks. And these are the block data when the transaction is done, that is digitally signed, and the data are encrypted and put into the block. Now, there is another definition given by Buterin, that he says that a blockchain, it is a magic computer where anyone can upload programs and leave the program to self-execute, like smart contract. You will come to know when it will be done in detail, that you can upload certain smart contracts in the blockchain network, which will execute like stored procedure automatically on, certain conditions are met, then those will be fired, like trigger fired in database, they will be fired and automatically it will run. And every programs are visible. Here also, one program which is uploaded, you cannot change that program. If you want to change the business logic, you have another version uploaded. And that will also go into the chain. It's again a blockchain. So everything is transparent and publicly visible to the member of this blockchain network. And it is secured because cryptography is used for storing the data. And it ensures that this program will not be changed by anyone else. That cannot be hacked. And it will run the way it should execute, exactly the same way this blockchain protocol has specified that this particular program will run this way. So this is non-hackable in this sense. If you look at the structure-wise, see the blocks here. The first block is the genesis block, whose address is, hash is 0. And here the data in the encrypted form are stored in the block. And it also stores the hash of the previous block. The hash with the data is used with the algorithm that will be later on taken care in detail. And each blocks are connected this with the previous hash. See, this previous hash is the hash of the block number 1. Block number 3, previous hash, is the hash of block number 2. It is connected. If somebody tries to change the data, then hash will be changed. And all the blocks, subsequent blocks, needed to be changed in order that when the new block comes, before that it should be done. But that is not possible. So this becomes immutable. I'll come to the properties. You will understand in detail that some fundamental properties of blockchain is to be implemented in order to have the full benefit of blockchain. Now, as I said, this blockchain technology, this cryptographic security is very important part. Now, this cryptography security is implemented using asymmetric cryptography, where a public and a private key pair has been generated. And this public key it is shared with everyone. It lies in the public domain. And this private key is a secret key. That is a pair of this public key, which is kept with the person who will have the access. So whenever any transaction happens in the blockchain environment, the data or a message, this message means some data you consider, that is encrypted with the private key, and that is sent to the public key of the receiver. And a signature, digital signature, is placed on the hash of the data, and it is sent. At the receiver end, the public key is used to decrypt it, the signature, and the data are verified. You will see that where this public key and private key lies, it is in the cryptocurrency wallet. The wallet stores this key, which can be used for any transaction to happen. So to sum up the thing, a transaction is encrypted by private key of the sender and sent using the public key of the receiver. You just have the analogy with the email system. The email ID, we write to, say, Meena Desai. That means we are sending it to Meena Desai. So Meena Desai is a public key of Meena Desai. Who is the sender? Say Niladri Shah is the sender. Then he enters the client software from where he is sending this particular email with the help of a password, which is his private key. So Niladri Shah is a sender. He enters with the password, which is the private key, and sends to Meena Desai, which is the public key of Meena Desai, which is available publicly. The receiver decrypts the transaction using public key of the sender. So, and accesses that particular data with his private key. Like Meena Desai will access the email by private key, by entering, password, and enters into the system and accesses those data. And by verifying with the public key of the sender, that means Niladri Shah's public key, decrypts the data. So this analogy, I think, helps to understand how transactions are digitally signed. So this digital signature, this ensures that each transaction is a valid transaction and it is originated from a valid source. That means Niladri Shah has entered into the system through private key and sending it to Meena Desai. So it has come from, he cannot deny this particular that I have not sent this email. Similarly here, the transaction, this non-repudiation, that means he has to accept that this has been originated from Niladri Shah. Confidentiality, because it is encrypted, it's confidential. Authenticity, because the person who is connected has entered through the private key, so authentic. Integrity, it is not tampered, because on the way, throughout the way, it is on transit also, it is encrypted, and it is decrypted only by the public key of the sender. So integrity, non-repudiation, authenticity, and confidentiality, these are all achieved in any transaction which happens in blockchain. Another thing, like blockchain in the business and finance domain, people tell this technology by another name, that is called distributed ledger technology, that's blockchain. So generally we have three categories of network: the centralized network, decentralized network, and distributed network. In centralized network, you have a central server system, and other nodes are connected to the central system. Central system controls all the nodes and the main data lying at the central server. You have a decentralized network. That means it's not centralized, but there are many central servers, and each servers have certain number of nodes connected to it, and the central servers are interconnected with each of them. And the third one is distributed network, where there is no central server. All nodes are connected by some means. Blockchain uses this distributed network in order to have this decentralized nature. I mean, there is no central authority or a middleman or a third party who will control and keep the records in their custody, so that later on or any point of time they can have access and manipulate those data. That is not there in blockchain. The beauty of this architecture lies here, that is truly peer-to-peer connection, peer-to-peer transaction without management of a central authority. But our digital rupee, I think that is being brought about by Indian government through central authority. I don't know how they're going to implement. I think in the next month, they are going to come up with detailed strategy how to implement. So now when you talk about a blockchain, the blockchain must have some fundamental properties and some other properties which is to be implemented in order to have full benefit of blockchain. The number one is distributed. All network participants have a copy of ledger for complete transparency. That means each node, like this is a distributed network where the users are registered, some nodes are registered. These nodes will be maybe minor, may not be minor. And all the nodes, all the participants of the network, they will have a copy of ledger, the transaction which is happening peer-to-peer between any two members, for complete transparency. So this maintains transparency. So distributed computing, distributed network is one of the important features of blockchain. Number two is immutable. Because whenever one block is written, the records are irreversible, that cannot be changed or deleted. It's permanent record. So it is called immutable. And a transaction timestamp is recorded on a block. When you will come to know the structure of block, it will be taken care in detail. It should be unanimous, because here, suppose Meena Desai is becoming a member of, say, any particular blockchain, and she's the participant, her name will not come as Meena Desai is buying this many cryptocurrency or something like that. That is basically a hash code, a public key in hash that represents Meena Desai. So it is completely anonymous, and this identity of the participant is not open, but it is trackable. With that particular public key, you can track all the transaction, and a copy of ledger can be obtained from the network. And there are consensus, which is called unanimous. That means all nodes will give consensus for the validity of the record, and then only a block will be written. All the records are secure, individually encrypted, so they are secured. So security is there. And the blockchain is programmable. That means you can upload all your smart contracts, which stores the business logic, so that it can be executed depending on certain conditions met. So to sum up, one of the most essential feature and a property of blockchain is this distributed ledger. And ledger copy is every node is having a copy. So whenever somebody tries to hack it, he will not be able to hack all these sites at a time. It's lots of computing power, electricity, and other things required in order to hack. So public ledger provides every information about a transaction and the participants also, but not by the original name, by the public key. So this particular architecture is transparent and trackable. In private or federated blockchain, public cannot enter into that blockchain, but those who are the participants of the blockchain, all of them can see what is happening by looking at the ledger. Decentralized. The network is decentralized, meaning that it does not have any governing authority or a central server or a single person looking after the framework. We can directly access it from the web. We can store our assets, starting from cryptocurrencies, important documents, contracts, other valuable digital assets, shares, dematerialized commodities. Anything can be stored in the blockchain. Direct access is done using private key. So we can see the decentralized structure that gives the common people power that this is my thing. Nobody is intervening into it. Nobody other central agency is controlling it. It is my asset, my right. So this way the society and the economic system may change if blockchain is implemented. This immutability is another important property, which means that something cannot be changed or altered. This is one of the top blockchain features that help to ensure that once a block enters into the chain, it is a permanent thing. It cannot be altered at all. Blockchain's integrity is made possible because of this immutability, because of the hashing that will be taken in detail at length as we proceed through our presentation. Data once stored cannot be corrupted and changed in any possible way. So data integrity is maintained. And so this is one of the most key feature of blockchain. Timestamping, I've already told you, that will give you exact time when the record was generated and the block was written. That is stored in the block. Before the block goes into the chain, consensus algorithm runs. Here you see consensus is not given by people. We say that node gives consensus. Basically, this is the consensus algorithm, which are predefined program that will run and give consensus to write the block. That will also be explained in detail later on. So this is a kind of, mining process. Through mining process, they will write a block by giving some puzzle will be given, that will be taken care in detail later on by Niladri Shaha. So that time you will understand how mining process is done. But once mining is done, then the consensus is obtained by the losing miners, and then the block enters into the chain. Without consensus, it has no meaning. That will not be entered into that valid chain. So enhanced security, I have already explained you that cryptography hashing is used, block is hash function, hashed, and the previous blocks hash is also kept into this. So this is security, and double security is ensured because each transaction is also digitally signed. And then each record is also kept in a hash form. So this blockchain architecture, it is programmable by using smart contracts. That also will be taken care in detail. But I'm just giving the overview that you can program a blockchain. Anonymous, because identity of a person like, Satoshi Nakamoto, that he is pseudonymous. We do not know who is he, but he has given this particular Bitcoin to the world, and Bitcoin, the value has rose to around 35,000 USD today. Public key, private key, I've already explained you, that are used for this transaction, and they are there in the crypto wallet. Transparency and traceability is maintained by this implementation that I've already explained you. The only drawback which we have here is the redundancy. Like blockchain is a complete network where we keep the same copy of the ledger in all the nodes. So redundancy of data is there. And to ensure that each node can participate, each transaction information needs to be stored and verified by each node, so that repetitive jobs are to be conducted by various nodes. And this data redundancy, keeping the same copy so many places, that is a little bit drawback. Now let us look at what are the different types of blockchain. There are three types: public blockchains, private blockchains, and consortium blockchains. If you look at the aspect of the participants, now in the public blockchain, they are without permission, permissionless. Anybody can hook on to that public blockchain like your Bitcoin. Their identity is not maintained. I mean, that is anonymous and could be malicious also. Some darknet may be using some blockchain technology and some currency and maybe doing trading into that. So that is possible with the public blockchain. With the private blockchain, that is permission blockchain. There, identified organization or identified member can join with the permission. These blockchains are trusted blockchains. This can be for any organization or enterprise solution. If we want to have in blockchain, we can have this private blockchains implementation. Consortium blockchain are permissioned. There, few organization for example, healthcare, there, few organization can form a consortium and keep the patient record. The research organization will take data from there. Some other hospital will also have the history data of some patient. So that kind of consortium can be formed, which is permissioned. Only permissioned nodes will be able to have the access, and it is trusted. Now, consensus mechanism, if you look at, then in the public domain, proof of work is required. Proof of work that will be explained in detail by Niladri Saha. That is basically one algorithm which will say that this particular block has been that particular block is created with proper norms. The proof of stake, this will also be explained in later part of our presentation. But in the public thing, large energy consumption is there, and 51% consensus will allow writing of a block. In case of the private blockchain, there is a voting system, multi-party consensus, algorithms are pre-written. In the private, they say that these are the members who will give consensus that will be executed that way. So it is lighter, faster, low energy consumption, and it goes towards finality. Here in the public, what happens? If 51% is not giving consensus, then that block will not be written, and the whole energy will be lost. So it is not going towards finality. For the consortium also, suppose 3 organizations make a consortium and implement a blockchain. So they themselves decide that what will be the consensus algorithm. They write it as a smart contract and put it. And here also low energy consumption. You can go towards finality of writing a block. It is lighter and faster. And transaction approval frequency, it requires 10 minutes around for the Bitcoin. And in public, it may be more than that. And for consortium, very less, 100 milliseconds. And private also 100 milliseconds. That depends on your implementation part. Like for Ethereum, Ether, only 15 seconds it requires to write approval of any particular transaction. So now we have more or less understood basics of blockchain. Blockchain, there is a distributed ledger, distributed computing environment, there is cryptography, there is data storage. So then the question comes into my mind that today we are using relational database for our application in banking and various other sectors. So what is the difference? What is the difference between this relational database and the blockchain? So that's why I've given this particular slide, but this is altogether a different concept. Blockchain and a relational database is altogether a different concept, but this will come into our mind because we have been working in relational database for a long period of time, and today banking sector, everywhere we find that database works and give a scalable implementation. So blockchain is decentralized, no third party. No centralized controlling authorities there. In the relational database, it is centralized. Say for example, banking having the custody of those data. Blockchain is peer-to-peer model, direct, without any intervention of middleman or a middle party. And relational database is client-server model. Blockchain is slower, relational is faster. Blockchain is very costly solution. Relational database is cheaper solution. In blockchain, you have only write and read operations only. You cannot delete and update because it is immutable. Relational database, you can create, read, update, and delete records. Blockchain has data integrity because everything is encrypted and digitally signed. All transactions are digitally signed, so data integrity is there. And the relational database doesn't have any data integrity. Blockchain is transparent. Everybody can see through what is happening, who is doing what, it is trackable. But here in relational database, because the central agency is keeping the log, bookkeeping, everything in their own custody, everybody like suppose I want to see my bank account details. I can see my transaction, what I have done, what are my debits, credit, everything. But that is not visible to the others. But in case of blockchain, everything is transparent. You can see that who has done what, it's trackable. So now I will tell you this blockchain, certain use cases where we can use this blockchain technology. So broadly speaking, if you see that where you require certain transfer of value, in case of share transfer, the transfer of share from one person to another, there also you can have this blockchain implementation in mutual funds or any fintech where there is a transfer of digital asset or physical asset or land records, where there is a transfer of some value or a name is happening, there you can have blockchain implementation. So land record, government's land record is a very good use case. Storage value, monetary transaction, cryptocurrency, value. Cryptocurrency is basically, transfer of value only. You have, say, certain number of Bitcoins, you transfer it to somebody else, peer to peer. So this is a store of value only. In the crypto wallet, we store the value of Bitcoin or any currency, say Ether or some other currency. So where you require trusted data verification, trusted. You don't trust a third party, you trust the algorithm. So here in the blockchain, the thing is that the third party trust has been replaced by cryptography, protocol, and computer code. These are replacing the central agencies to whom we have been, putting our trust and keeping our data in their custody. Voting system, like voting also, this is a very good thing for election voting and all. And any kind of decentralized app, we can have this blockchain as a solution. And if you see the application area of the blockchain, then cryptocurrency, the most hottest in today's world, banking, insurance, fintech, IT cloud storage. This is also within, storage also, non-tempered, permanent records, blocks can be created in IT cloud. Supply chain, healthcare, real estate, crowdfunding, funding and sharing those funds. That is another economy where you can have this blockchain technology. And legal also, and Internet of Things. This Internet of Things is also one of the most disruptive technology, and this true disruptive technology can club together and can come up with fantastic solutions and applications. Sorry. So before going into the blockchain technical details, I'll just wrap up with this cryptocurrency, and then I'll hand it over to Niladri to explain the nitty-gritty of blockchain, its terminology, what is mining process, what is smart contract, what is Merkle tree, how they are implemented, those details will be taken care by him. Now, this cryptocurrency, this is a digital payment system. There is no physical coin or a digital coin or something coin like that. Crypto is basically a payment system peer-to-peer that does not rely on any third party, that verifies all the transaction that happens by sending and receiving. The sending and receiving is done with the help of crypto wallet. This crypto wallet keeps the private key. If you forget your private key, then you cannot simply, it's gone. That money has gone. That crypto has gone out of your wallet. You cannot just revoke that particular thing if you forget your private key. So cryptocurrency is it's something where you can send and receive payments peer-to-peer. And this crypto name is given because it is encrypted. Every transaction is encrypted and they are verified. It is a store of value. It's not like that that ye hai 10 rupees ka, ye hai 100 rupees ka, nothing like that. It's a store of value. You have Bitcoin, say I have 10 Bitcoins. Okay. And they are transmitted using these wallets. And each transaction goes into the public ledger. And they are in the encrypted form. And then they are hashed and put it into the block that he will come into detail. So cryptocurrency transactions are recorded in public ledger and stored in public wallet. As simple as that, if you can understand, because implementation is very complex. But if you look at the cryptocurrency from the user level, it is as simple as that. You have a crypto wallet. There you have a private key. You access it. Send this crypto. Say 10 numbers you are sending to from A to B. So all 10 will be blocked at that time. So there is no double spending. So basically, this electronic payment system, which Satoshi Nakamoto wanted to implement, so he was finding that there is some double spending problem. So in order to sort out that problem, he came up with this Bitcoin solution using this blockchain. So cryptocurrencies run on a distributed public ledger called blockchain, and a record of all transactions updated and held by currency holders. So if I am a currency holder, then I have all the records, whom I have given, when, what, everything. And the copy is there lying with the other nodes also. So units of this cryptocurrency, small cryptocurrency, these units are created through a process called mining, which will be explained in the later part of our presentation, which involves some computing power to solve a very complicated mathematical problem. And the node which solve this particular problem first will get the reward of that coin. This way the crypto coins are generated. Users can also buy this currency from brokers, because broker is selling, but they are created by mining process only. There are crypto exchanges are there. They do mining, and then through the broker system, they can put it in the market. They can store, spend, and use by using this cryptocurrency wallets. You can store the cryptocurrency in wallets. Spend also through wallets. And cryptocurrencies are non-tangible. So you don't own anything. Physical asset is not there behind that. What you own is just a key. It allows you to move a record from one person to another without a third party trusted. And it is a unit of measure, you know. They say that 1 million Satoshi is 1 Bitcoin. Satoshi is the subunit of your Bitcoin. So you can have, fraction of a Bitcoin also with you. So this Bitcoin, there are a number of cryptocurrencies running into the market in present day. Bitcoin is very famous, and the first, which was implemented by Satoshi Nakamoto in 2009. But it was not very popular at that time. It got its popularity in 2014. And then this Bitcoin prices started, people started trading like share. They started trading into this Bitcoin. And it is based on the demand and supply. The prices change according to demand and supply. It has become just like an asset. It is not a legal tender in most of the countries. Only one country has given it as a legal tender, but the other countries, many of the countries have banned it. In India, it is not banned as such, but this year government has said that kind of 30% of tax on any kind of digital asset you do, because it is trackable. Now, how they are going to implement this particular aspect, that will come maybe in the month of March or so. Now, the third example is Litecoin, Dogecoin, many things are there. This Litecoin is similar to Bitcoin, but it moves very quickly. I mean, it is faster, payment is much faster than Bitcoin. And it allows more transaction to be processed in a very small amount of time. Another is Ripple, which is a distributed ledger system, which was founded in 2012. And it can be used to track different kinds of transaction also. So other than cryptocurrency, you can use this in other fintech solutions. The company behind this works with the financial institutions and banks to come up with some more solutions other than this cryptocurrency. So, and what all other coins other than Bitcoin, we call them by the name altcoin. So that original, to just distinguish it from the original. Original is Bitcoin. Now, Bitcoin, this blockchain platform, there are many open source blockchain platforms are available. We are using this Hyperledger and Ethereum for our development. But there are Hyperledger, which is the open source based on the Linux, Ripple, Ethereum, Red Belly, Stellar, Forum, OpenChain. These are all platforms. Using this, we can have implementation of various applications in blockchain. So now we are going to enter into more technical details. Till that, we have understood what is blockchain, why blockchain, what is, why, how will be taken care in this part of by Niladri Shah. So handing over to Niladri Shah.
Good evening, everyone. This is Niladri Shah. Thank you, ma'am. Ma'am has nicely explained various concepts of blockchain. I will show you the insights and I will explain the technicalities of blockchain. Before I start my presentation, I want to put some food for thought in front of all of you. Through internet, by using email, we can share our document, we can exchange messages. But one thing we cannot do. What is that? We cannot exchange values. Why? Why we cannot exchange values through email? Can we send money directly through email from one account to another account? No. Why this is no? Because of trust. You cannot trust recipient completely. After getting the money, if somebody denies that I have not received any money, then you have nothing to show for as a proof. So to solve this problem, what we generally do, we put one third party between two parties. What is the name of the third party? Name of the third party is bank. So we put bank in between two parties. So what bank is actually giving us? Bank is actually giving us trust. They have KYCs of person A and person B, and they have all the transactions as a ledger. So after getting money, if person B ignores that I have not received any money, we can show that this is my bank statement. Now you can check, I have given you the money. So are this trust is given by bank free of cost, or we are paying something? Yes, we are paying something, not the transaction fee only. We are compromising our financial independence. Why? Because suppose I have money in my account and I want to transfer some money to other, and at that point of time bank server is down. Then what happened? Can you send money? No. Even if you have money in your account, you cannot send the money to other person. And the servers of the bank are controlled and are managed by a centralized authority or some people. If they want, they can tamper our records. So to overcome this sort of problems, blockchain have given some solution to overcome this kind of problems. So what is the blockchain ecosystem? Blockchain is simply a data structure where each block is linked with another block in a timestamp and chronological order. Means block A is linked with block B and block C is linked with block B by the previous hash. So block B has the hash, block hash of block A, and block C has the block hash of block B. First block of the blockchain is called Genesis block. First block of the blockchain is called Genesis block. Previous hash of a Genesis block is 0, as there is no block prior to it. It is a distributed digital ledger. See, in the bank is maintaining a centralized ledger, but in the blockchain or in a Bitcoin, it is a distributed digital ledger that is immutable public record of digital transactions. So Bitcoin is maintaining a immutable public record of digital ledger. Every new record is validated across the distributed network before it is stored in a block. Before a transaction is getting stored in a block, it has been validated by maximum number of miners, right? Consensus you have to get the consensus of maximum number of miners, majority of miners, before putting this block into the blockchain or putting this transaction into a block. All information once stored on a block, it is verified and auditable but not editable. Means the record in a blockchain is immutable. Each block is identified by cryptographic signature. What is the name of the cryptographic signature? The name of the cryptographic signature is block hash. So every block is identified by its block hash. Now, Now, hash algorithm. I have told that every block is identified by is block hash. So what is the algorithm that are being used in this particular technology? SHA SHA-256 algorithm is used in blockchain technology to get a unit block signature, that is block hash. Why SHA-256? Why not other algorithms? The answer is, although many hashing algorithms are present in the market, research has proved that SHA-256 algorithm is the most efficient in blockchain technology. So we are using SHA-256 algorithm as a hash algorithm for blockchain. What is the properties of this hash algorithm? Properties are, number one, this is one way. Means if you give some data, you will get a unique hexadecimal pattern, right? And this is deterministic, means same data will give you same hash every time. Suppose as an input, I give my name Niladri Shekhar Saha, I will get some hash. If I give the name 10 times, then also I get same hash. But even if a small change in the data will give completely different hash. If I change something in the input, I will get completely different hash. This is called avalanche effect. Fast computation is very fast in this algorithm and must withstand collision. That means as long as the data is same, you will get same hash. Different data will give you different hash, right? You will not get same hash code for different data, right? These are the few properties of hashing algorithm. Now, this is blockchain workflow. What is the workflow of blockchain? How blockchain works? Suppose someone requests a transaction, then the transaction is broadcasted to a peer-to-peer network. Means this particular transaction will be forwarded to all the miners through peer-to-peer network. Then validation part, the network of the nodes validate the transaction, right? The network of the nodes validate the transaction. The verified transaction can involve cryptocurrency, contracts, records, or anything of a value, right? Here in the blockchain, we are trying to share values, right? So the verified transaction can involve cryptocurrency, contracts, records, or anything of a value. Once that is verified, the transaction becomes a part of a new block for a ledger, right? Once the block is verified, the transaction under the block and the entire block itself becomes a part of a new block for the ledger. Then the transaction is complete. This is a small workflow of a blockchain application. Now, how transaction propagates in a distributed network? Suppose a node in a network find a transaction. The transaction is Paul wants to pay 5 coins to Lisa. Then the node A will broadcast this transaction to its peer, that is B and C. Then the nodes A, B, C will check the basic formats of this transaction, and if it is all right, then they will forward this transaction to their peers. Like this, the transaction propagates rapidly across the network, right? The protocol that we used in this particular peer-to-peer network is gossip protocol. So we are using gossip protocol for means transaction propagation in distributed network. But problem is, who will validate my transaction? In a banking system, this responsibility is taken by bank itself, right? Now we have omitted the middleman, that is bank. Then who will validate the transaction? Right? There are some special nodes in the blockchain network that will verify the transactions and maintain the ledger. We call them as miners. So in a blockchain network, there may be a n number of nodes, but there are few special nodes in the network whose responsibility is verify the transaction and maintain the ledger. We call them as miners. Then who are the miners? Right? Miners are the special node with ASIC circuit. For becoming a miner in Bitcoin, you have to install ASIC circuit, application specific integrated circuit, and you have to download all the transaction, all the blocks of a blockchain in your system. Then you can verify the nodes, verify the transaction, and perform mining operation, and you will become miner. So for becoming a miner, you have to install a special circuit. The name of the circuit is ASIC circuit, application specific integrated circuit. Right? Miners hold the copy of the ledger and verifies the transaction happening in the network and maintain the ledger. So what is the job of a miner? The job of a miner is hold the copy of the ledger and verify the transaction happening in the network and maintain the ledger. Using the state-of-art cryptographic algorithm, that is proof of work, right? Using a state-of-art cryptographic algorithm, proof of work, miner validate transaction across the network. So are the miners validate the transaction manually one by one? No, they are using one cryptographic algorithm. The name of the algorithm is proof of work. Miner will get rewards for creating a block by halving mechanism. What is that? So mining operation is not very easy. Creating a block and putting this block in a blockchain requires a huge number of energy that consumes huge amount of energy, and it requires a huge computational power, right? So miners will get rewards for creating a block by halving mechanism. In order for our digital monetary system to work, the miner must be able to ensure the following details. So what are the details that miner must be ensured? The details are: originator of the transaction possesses the fund of being transferred. Means the person who wants to send money, he or she must have the amount in his account. This is validated by miners. And second thing is, the organizer of the transaction has obtained the fund by one or of the means commonly recognized as valid. Means the amount that the organizer of the transaction have, that must come from a valid source, right? These two things are being verified by miner for every transaction. Now, most important thing, mining and consensus process. How mining happens in Bitcoin? I am showing the mining process of Bitcoin. Suppose user A wants to transfer 1 Bitcoin to user B. User A wants to transfer 1 Bitcoin to user B. So this is a transaction. This transaction will go to a unconfirmed transaction list, distributed unconfirmed transaction list. The name of the list is called mempool. So every transaction will go to the mempool. So we can say mempool is a scalable storage for unconfirmed transaction. From mempool, the miner, suppose in this network there are three miners, miner A, this one, miner A, miner B, and miner C, right? Three miners are there in the network. Every miner want to create a new block. Why? If they successfully able to create a block and put this block in a blockchain network, he will get some reward. For that, every miner A, B, and C will participate in the mining process. First, miner will create an empty block. Right? In the empty block, what will be there in the empty block? The block height, means block number, and previous hash of the block. Right? So every miner will create one empty block. Then they pick unconfirmed transaction from the mempool and put them into the empty block. So every miner will pick some unconfirmed transactions and put them into the transaction list of the empty block. Then one more important thing, the average block size is 1 MB. You cannot create a block whose size is more than 1 MB. So approximately 1K to 5K transaction can hold in a block. So every miner will put 1K to 5K transaction and put the empty block. Now they will participate one competition. What is the competition? By using proof of work algorithm, Bitcoin network will throw some puzzle to every miner. Miners have to solve the puzzle, and every miner will use their computational capabilities to solve the puzzle. The correct answer of the puzzle is called nonce, number you use once, right? The correct answer of the puzzle is nonce. Who will give the puzzle? The blockchain network, Bitcoin network will give the puzzle, and every miner has to solve the puzzle. The correct answer of the puzzle is nonce, number used once. The miner who find the nonce first will be declared as winner. So miner A, miner B, miner C, three miners are competing in a puzzle. The miner who can find the nonce first will be declared as winner. Then what happens? The losing miner will inspect and validate the winning miner using consensus algorithm that is called proof of work. By using proof of work algorithm again, the losing miner will validate the block details, new block details of the winning miner. Right? What they will inspect? They will check whether the block size is less than 1 MB or not, whether the previous hash code is correctly picked from the blockchain network or not, whether the miner has used correct ways or right ways to get the nonce, whether the nonce, what the winning miner has get, that is correct or not. Everything will be checked by the losing miner, right? After successful validation, the winner will get reward, and the winning miner will put the block into the blockchain network, and the new copy of the blockchain will be distributed to all the miners. Approximately 10 minutes is will be taken by the miner for putting one block in Bitcoin network, right? For completing all this process, that will take approximately 10 minutes. Now next is structure of a block. What is the structure of an individual block? The structure of a block is, first there will be a version number, right? Version number of a block. Then nonce means the result, the correct result of the puzzle, that is called nonce. The winning miner has to put the nonce into the block. Then previous block hash, the previous block hash should be there in the block, and timestamp of the block. Then one important thing, Merkle tree. I will show you. I will describe in detail about the Merkle tree in my later slide. As of now, please keep the note that in a block, Merkle tree or Merkle hash will be there. Then list of all transactions. So this is a simple structure of a block. These are the things that should be there in a block, right? Header part, there are actually 3 parts of a block. First part is header part that contains version info, nonce, previous block ID and timestamp. Then in the next part, Merkle hash, and in the last part, list of the records, right? Then the Merkle tree. What is the Merkle tree? A block contains a list of transactions. Each transaction are hashed again, and the hashes are then paired. Means suppose L1 is a transaction. Let me show you by using arrow, right? Suppose L1 is a transaction. Sorry. Suppose L1 is a transaction. We have to calculate the hash of L1, and we have to then next transaction is L2. We have to calculate the hash of L2. Then we have to club 2 hashes and make one new hash. Suppose the name of the hash is hash L12. Then again, using the same process, we have to calculate hash of the L3 and hash of the L4. Then we have to club those hash, and that we will take, in this way we will get one hash for all the transactions by clubbing all those hash one by one, right? We will get one hash. There the name of the hash is Merkle hash. We have to put the Merkle hash in the blockchain. That will give another level of security in all the transactions, right? This Merkle tree is also known as binary hash tree. This is used for summarizing and verifying the integrity of large set of data, that is list of transactions. It contains cryptographic hashes, right? Cryptographic hashes of all transactions are clubbed into one hash. The name of the hash is Merkle hash, and the miner has to calculate the Merkle hash and put this Merkle hash into the block before put the block into blockchain. Then proof of work. Proof of work is a piece of data which is difficult. Difficult means difficult in terms of this is costly, time consuming to produce, but easy for others to verify, and which satisfied certain requirement, right? What are the requirement? To keep the coin distribution predictable, puzzles becoming increasingly difficult to solve when more people work on them. The part of the Bitcoin solution is that each block must contain the answer of to a special math problem, right? So the problem, what I have explained in the mining process, the Bitcoin network will throw one puzzle, right? The puzzle will be thrown by using proof of work algorithm. This puzzle is very difficult to crack, but easy to verify, right? Then there are 3 components which help in achieving the proof of work solution. Number one is nonce. Nonce is a random number whose value is set to that the hash of a block will contain and run the leading zeros, right? The more number of zeros in a nonce, more difficult problem to solve, right? The rest of the field may not be changed as they have to define as they have a defined meaning. The hash is a fixed length number which results in large unchanging data when read. Transaction, what is transaction? Authentic transfer of Bitcoin ownership collected and recorded in a blockchain. This is actually a proof of work algorithm. By this algorithm, a new puzzle is generated after 10 minutes, right? Automatically. And by using this algorithm, the loser nonce will verify the validity of the transactions and the validity of the block, right? Then some problem statement, if more than one block gets solved at same time, suppose one or more miners solve the puzzle at the same time, then what happens, right? Then the longest chain will be given preferences. Suppose nonce A and nonce B have solved the same puzzle at the same time. Then everybody then two miners can add the block in the blockchain network, but that is not possible. With same data, two blocks will not be accepted in a blockchain network. Then how to solve the problem? The block which is longest chain will be given the preferences, right? Then what if miner tries to cheat with the system? Suppose miner wants to cheat with the system. Suppose miner wants to tamper the records. Since there is a reward for solving a block, there are chance that miner might give the wrong solution to the block. What happens in such cases? After creating a block, miner has to publish the block with proof of work to the network, and other miners will validate the block to ensure the authenticity, right? If the proof of work provided is wrong, then block is considered to be invalid, as a result of which the miner end up exhausting their resources without getting any reward, right? If somebody tries to cheat with the system in proof of work by using proof of work algorithm, when losing miner will validate the record, they will find this particular miner has cheated with the record, and the block will be cancelled. So the winning miner will exhaust his means resources without getting any reward. Therefore, the consensus mechanism does not allow anyone to cheat with the system, right? Then what if someone tries to hack the system? If some third party wants to hack the system, what if somebody tries to alter the transaction in a block? Once the block is solved, cryptographic hash output becomes the identifier of the block. So if someone tries to alter any transaction of any block, the hash of the block will be getting changed, right? And that will be reflected in next block, and then next block, and so on. So, and even if the hacker is successful to change the record or to alter the record, then it can maximum change in one node. But as we are using a distributed system, it is impossible to change the record in every minor node, right? Every minor node in millions of computers. It is impossible. So the system is impossible to hack. Right. Then smart contract. What is smart contract? Smart contract is a very secure and immutable code for storing rules, verifying rules, and self-executing rules. Right. Suppose you want to buy some car, and you want, so for that, what you have to do? You have to make one agreement with the car seller, right? And this agreement is manual agreement. But in the smart contract, we are doing this agreement programmatically, and the smart contract will work like a trigger and ensure all the possibilities, right? That is written in the smart contract, right? So what are the difference between traditional contract and smart contract? Traditional contract is third party driven, right? Government or lawyer are involved in traditional contract. But smart contract, this is a automatic code, right? This is a program. No involvement of third party is there in smart contract. Execution time of a traditional contract is 1 to 3 days, but execution time of a smart contract is few minutes, as it is automatic. Then this is the traditional contract is a manual process. and smart contract is a automatic process. Transparency is not available in traditional contract, but transparency is available in smart contract as it is distributed among the entire blockchain network, right? Archiving, it is very difficult to archive the huge number of paper documents in the traditional contract, but in the smart contract, it is very easy to archive. Security, in the traditional contract, security is limited as it is controlled and stored by a centralized authority. Everybody can tamper the transaction, but in smart contract, that is cryptographically secure. Smart contract is cryptographically secure. Cost, traditional contract is very expensive, but smart contract is very cheap. These are few lines of code. Signature is a manual signature is there in a traditional contract, but in smart contract we have to put digital signature, right? That is the difference between traditional contract
Mr.
and
Saha, if you can
smart
wrap up fast, because a lot of questions are waiting.
Okay, yeah. So I am giving the example of smart contract. AXF flight delay insurance is one of the example of Ethereum smart contract, right? What they are doing, a smart contract is created based on the terms and conditions. Based on the code, smart contract holds the company's money until a certain condition is satisfied. This smart contract is submitted to the nodes on EVM for evaluation. All nodes on the network executing the code using the EVM must come to a same result. Then, if the flight is delayed for 2 or more hours, the smart contract will be self-executed and a compensation amount will be given to the means retail, right? Suppose retail buys a insurance from a AXA flight delay company, then and the flight is getting delayed for 2 or more hours, smart contract will be executed automatically and he will get his compensation, right? Then advantage of smart contract, this is there is no intermediaries in smart contract. Speed is very high. The smart contract is an automated process. It is very secure and it is very accurate, right? Then this is a blockchain landscape. These are the means platforms for public or private cloud. We are using digital asset, Tendermint, Casper, NAS, DAQ, then SCTL, Ripple, Chain, etc. For private consortium, RC Coda and Sentinel, right? Yeah, open source platform are used, multi-chain and Hyperledger 1.0, and Ethereum or Bitcoins are there, right? For public and private blockchain. And the consensus algorithm, the most popular consensus algorithm as of now is proof of work. Ethereum is using proof of stake also. Application and use cases, these are the applications and the use cases: trade finance, commercial paper trading, assets, right? Accounting and assurance. These are the applications and use cases, and industry consortium are Hyperledger, R3CV and PTDL group, right? Then pros and cons. The pros are blockchain is highly secure and it cost low cost of transaction, faster processing time, fee of friction, assets are controlled by owner, verification is independent, more transaction trust, it is completely transparent, so it is safer. And cons are not suitable where data is to be deleted. The high energy consumption is required for mining. The scalability issue in Bitcoin supports far less transaction per second. It is comparatively slow from Visa, right? Visa transactions. It opens up possibility for money laundering. Some blockchain, right, like Monero, are supports anonymous transaction, right? Anonymous user. So money laundering can happen. The question remains as to how far we want to bypass the middleman, right? often we can also protect, often he can also protect us. Bank can protect us to an extent that we do not transfer the money to the wrong person, right? Then conclusion, the possibilities of blockchain technology are truly endless. The development in recent years have taken us one step closer to decentralized, trustless internet, transparency of transaction, and more. The technology is going to be game changer in the days to come. According to Gartner report, many new innovative companies will use it, and at least one business created using this advanced technology would be worth 10 billion by 2022. By 2030, it could be used as a fundamental technology for 30% of global customer base. So that was my last slide. Thank you, all of you. Yeah.
So thank you, Ms. Meena Desai and Mr. Saha for illuminating talk and excellent renditions on the particular subject. It is a most disruptive technology as on date, and which can change the ball game altogether. So you have spared most of your valuable time to give us this illuminating talk and the intricacies of this particular technology. Now, without these things, I do not want to elaborate. Now, lot of questionnaires have come from the participants. I will just read out because we cannot take out all the questions, but a few questions, of course, we can take. Is this blockchain framework also feasible to implement in real estate and property registration?
Yes. Property registration, land record, who is selling to whom, that particular record can be immutably stored into blockchain.
Yeah, already we have discussed.
We are giving solution to Hyderabad, the state, Telangana state.
Okay. Now, next question is Mr. Dinesh Chahanna. He has asked for what is the relation between blockchain and NFT?
Blockchain and
NFT.
NFT.
Yeah, NFT. Yeah.
NFT.
See, okay, we can. Please.
Blockchain is basically
non-fungible token.
So see, blockchain is basically, you have seen, where the value can be transferred or timestamping of any digital document can be recorded as a proof of But this NFT is a non-fungible token that is basically generally built using the same kind of programming like cryptocurrency, but there is no process of transparency and trust. But cryptography is there same in both the cases. In blockchain, you have cryptography, and there also, and like Bitcoin and Ethereum, this NFT. But the just hold on. There's a call from you.
Yeah.
So this NFT is basically can be traded through exchange. But blockchain is the technology. Using this technology, you can build NFT.
Okay.
That is the basic answer. I think the questionnaire has got his answer, or no?
Okay, then we can.
One of the application using blockchain technology is Bitcoin.
Bitcoin. That is NFT.
Right.
NFT is basically the application using blockchain. So this is the difference.
Right.
Have I answered the question?
I don't know the concern, the person who has answered the
question
question is there or not. But anyway, you have answered the question. Now let us go to another question. Commander Bhandarkar has asked, selfish miners may get higher payoffs by violating the information propagation protocols and postponing their mind blocks by exploiting the inherent block forking phenomena. Please comment on this security aspect.
Yeah, Niladri is.
Sir, can you please repeat the question?
Yeah, self miners may get higher payoffs by violating the information propagation protocols and postponing their mind blocks by exploiting the inherent block forking phenomenon. Please comment on the security aspect.
Yeah, security aspect is, suppose one miner is delaying the process, right? Tries to delaying the process.
Yeah.
Right? Then another miner will come up and solve the nonce first, and his block will be accepted in the blockchain network,
And he will be rewarded for that
and you will be rewarded for, yeah, you will
with
be
the
rewarded for
Bitcoin or some cryptocurrency.
Correct. Mr. Rajendra has asked one question. Our Indian mindset is somebody will do good for us and take care of us. We trust our public services, institution and government or politician. We surrender ourselves to them for needs. A group of bureaucracy or politicians taking people power and managing them, it's our social system. I think it's a more kind of philosophical these things. If you have some doubts, we can approach to courts, God and temple and cars, the stars, even the stock market. I think it's this question need not be discussed over here. Then whether and how cryptocurrency can be converted with normal currency. Ms. Papia Mandal has asked the question.
See, cryptocurrency and a normal currency conversion, that is basically depends on the government, because government will decide what amount of, say, Indian rupees will be some crypto. See, our Indian government has said that they are going to give a digital rupee which by RBI. So RBI is a controlling authority out here. I don't think they are going to give the crypto like Bitcoin or something like that, which is going to be traded like, depending on the demand and supply of that Bitcoin. Bitcoin, when it was generated, they have the algorithm said that 21 million Bitcoin only can be generated from the Bitcoin network, that implementation. Out of that, 17 million has already been created by this mining process. Now, cryptocurrencies are generated by mining process, like our Indian rupee, which is a legal tender that is generated against gold, by RBI. So the amount of gold will decide how much currency should be generated by RBI. But here, nothing has come up from the government that what will be the line, whether it will be a cryptocurrency or just the Indian rupee, a legal tender in digital form.
Okay.
It's not clear as of now.
Okay. Somebody like Mr. Adarsh Jain, as a layman, I buy a Bitcoin on WazirX platform. Is it blockchain transaction or WazirX platform is trustee or intermediary? I do not think it's a P2P transaction.
Oh, WazirX transaction.
Yeah.
It's a cryptocurrency.
Yeah. He's talking that if I buy a Bitcoin on WazirX platform, is it a blockchain transaction or WazirX platform is trustee or intermediary?
WazirX is a intermediate transaction. That is, you can say, like a broker is allowing the transaction of certain cryptocurrency.
Correct.
Like, share brokers are there who allow that share broker, that kind of.
Right. When there are multiple transactions being made simultaneously, what algorithm makes sure which blockchain block or transaction would be added first? I think it has been explained. With the longer chain of the blocks, it will be getting added, right?
That mempool, every transaction goes and time to time, this is picked up by the mining process, miners, and then the process.
Somebody has asked, what is the purpose of Ripple?
Ripple is a kind of a cryptocurrency, and the blockchain platform that can be used for any kind of application development.
Okay.
Any platform or a framework which is available in open source that can be used for any kind of application development, where you have to write your smart contract, some
Actually,
using some programming.
Actually, Ripple is the most advanced blockchain technology for global payment. Financial institutions are able to expand into new market around the world by using Ripple, right?
Right. Now we'll take only.
Fintech is basically financial transaction using the latest technology. That's the fintech, and this fintech 3.0 is making this blockchain enter into the new scenario, and there you can do any kind of financial transaction using this blockchain network.
Right. Now we'll take the last question from Mr. Mahesh Rathi. By nature, blockchain is distributed and no centralized governing is possible. Then how and what would be the blockchain implementation for Indian flavor when government indicates that it will be RBI governed?
Yeah, that's what I said. That has not come up from the government. Any, strategical publication has not come up from the government that how they are going to implement. I think they are just, because see, if it is crypto, then there is no physical asset associated with this cryptocurrency. But I don't think Indian government will go into that line. They are saying digital rupee. Central agency, that means RBI, is going to introduce CBDT, that is a digital currency, right? So that I think just to have a paper cost, paper printing cost to be reduced, we'll have a digital form of the currency, and maybe blockchain will be used for the implementation. They will generate this digital currency by mining process, and they'll keep the ledger. They will keep maybe this is all maybe, because there is no official tender of document which has come out which proposes that this is the way they are going to implement it. But what we think, that suppose the government is bringing something like Bitcoin, the digital currency, they will have the same value as the Indian rupee. And they will maybe using the blockchain technology for mining process, creating but at the back there will be some physical asset like gold and all for creating those things.
Okay.
Now, there is one question from Mr. Sadhon Ray.
Okay.
Yeah.
Yes, Mr. Ray.
Will a rich person without knowledge of computer be able to invest money for cryptocurrency?
Come up again. Without computer knowledge, what is?
Will a rich person without knowledge of computer be able to invest money for cryptocurrency?
Yes. This cryptocurrency is very easy. If you suppose want to say buy some Bitcoin, you just have 2-3 clicks. You have to register. Say suppose you want to go for Ether. So for Ether, you must have Ether crypto wallet and one password. That is your private key. You just create your account. And like your share transaction you do this crypto transaction. Depending, daily prices will be there, because they are generally not the legal tender like Indian rupee and all. They are just like a digital asset, like the share assets and the long-term and short-term assets we have. They fall into that category. So it is very easy. 2-3 clicks, you can just buy crypto and sell crypto. And they are connected with there are exchanges available. From there you can buy it. Through broker also you can buy it. It is very easy. Okay. But it is very risky. It's very risky. Your money will go in a day. See, today 5% Bitcoin has got down because of this Russia problem.
Yes.
So in a day, 5% of say 36,000, how much USD has been lost by a person? So it is very risky.
Yeah.
Okay,
and now Mr. Sachin Kumar has asked one question. We'll take this question and then we'll close it. How can we use this technology for supply chain of food materials?
Yeah. Supply chain of food materials. Niladri will explain you
Yeah.
how this can be used.
Yeah. Supply chain of in the supply chain of our food materials, the food particle, this process, the information of a food or information of a crop from person 1 to person n. Suppose the person 1 is the farmer, right? He is producing some crops, and this crop is being used by a company. So from farmer to company, n number of transactions are happening, right? If the qualities of the crop and the food particles, if we get that quality and put this quality record into the blockchain, and then nobody can change that particular record, food contamination risk will be much lower, and we can point out at what point problem is coming, right? If we keep recording, keep the transactional record in every point of transaction, then it is easy to fetch where is the problem, right?
Right. So now we can ask Professor Nitosh Kumar Brahma to give the vote of thanks. And before that, just I want to announce one thing. The persons who want to get the e-certificate, please register by tomorrow. Professor Nitosh Kumar Brahma, I invite you to give the vote of thanks.
Thank you, thank you, thank you. It is I can say it's a mega event. Today I have just gone through. It was a part of the subject matter is somehow not very clear to me also. The crypto in our definitions is somehow a twisted something, but I don't know how far it will be applicable to that cryptocurrency in that system. The main thing what I see before I give my vote of thanks, I just have to give some introduction. The main thing what I see in the Indian scenario is the productivity of the Indians is not developed, but we are managing somehow the currency transfer by various means. It is good. That means we have to survive. But at the same time, our productivity and the concept of the productivity must be very much aware to the young generation as well as in the old generations. That means we have to develop our own indigenous technology in that respect, along with the transfer of the currency as well as the modifications of the currency and all these things. You see, the whole world, if it is going with the dollar, it will be very easy to transact our products, to transact our concept, to transact our, what you can say, the economical balance and everything. When I was in Germany in 1968, I used to pay, or I used to send to my mother, old mother, some money, 100 Deutsche Mark. And she used to get only 300 rupees. You see how the currency is developing rapidly to the developing world, developed world compared to the India. Today, if one Deutsche Mark provides you probably 100 rupees, now you see the same work, same hard work, same type of activities. I could help my mother only with 100 or 300 rupees with the help of 100 Deutsche Mark. Now the concept must be so that we must rapidly develop our productivity along with the population's growth and the environmental protections as well as the infectious world in India. We must be very much aware. We must be very much technological movement towards that direction, along with the support of that type of cryptocurrency, as well as the other dollar and Bitcoin, all the moderated concept of our currency handling. With that short introduction, I start my word of thanks. In that respect, it is my proud privilege to extend my sincere thanks and the gratitude to all the distinguished participants in the technical webinar on the theme blockchain and cryptocurrency, organized by the Electronics and Telecommunication Engineering Division of West Bengal State Center, IEI, through online platform Zoom. At the outset, I convey my sincere thanks to the panelists, Mrs. Meena Desai, Joint Director, CDAC, Kolkata, and Mr. Niladri Shekhar Shah, Joint Director, CDAC, Kolkata, on today's technical webinar, who have very nicely deliberated their lecture. My sincere thanks also goes to my colleague Sri Shandip Kumar Dev, Chairman, West Bengal State Center. Today he is a Vice President. My heartfelt thanks also goes to Dr. H.F. Thakare, President IEI, Dr. G. Ranganath, Chairman Kate, IEI, Professor Dr. Girish Shikishan Mundala, Chairman, Electronics and Telecommunication Engineering Division Board, IEI. My heartfelt thanks also goes to Mr. Ramachandra Chakraborty. Today he was absent due to some personal work or health, I don't know, Managing Director, PSI, Metal India Private Limited, and a convener, IT Engineering Division Subcommittee and moderator of this program. The same feeling is also being now showed to all members of the council and division board members of ETDB. All members of the committee, West Bengal State Center, IEI, and all members of ET Electronics Telecommunication Engineering Division Subcommittee, Director Technical, IEI, and his team for the wholehearted support to make the program a success. This last but not the least, my sincere thanks also goes to all who were behind the screen and giving their silent support in this technical webinar. Thank you. I'm really glad to say these programs are essential to activate ourselves towards various possibilities to uplift the transactions, mainly the financial aspect. And that, I believe, one of the biggest challenge with our productivity. Thank you very much.
Yeah, Nitish Kumar sir, I want to add a few words. Thanks to many participants who have spared their time, and apart from the names Professor Nitish Kumar Brahma sir have mentioned, we want to thank Dr. Pradeep Javandia sir, Dr. Uttam Kalavne sir, Colonel Bhandarkar sir, Dr. Sadan Ray, Engineer Santosh Mutha, Dr. Vrinda Gupta, Engineer Brahma Reddy, Dr. KV Subbi Reddy, Kundli Kugle, and Chanchal Chakravarti sir for their gracious presence in making this seminar wonderful. And we had over 180 participants attending this seminar.
Thank you. Thank you.
Yes,
Very
sir.
great.
Thank you. Thank you.
Thank you. Thank you.
Thank you, sir. Thanks, Dr. Mundadar, for sparing your valuable time that you have from the beginning. You are now here till this time. And thanks to all our eminent panelists who have deliberated a huge lecture. And you have already seen that more than 180 participants joined, and more than 67 questions have been asked. So many questions people are, but we could not take all the questions. So we have to limit it and we have to filter it for the paucity of time. So with all these things, we can today we can conclude the session. Thanks to all the.
Thank you very much.
Thanks the panelists. Thanks, Dr. Mundadar. Thanks, Professor Prabhu, for sparing that time. So I think we can conclude
maybe
it.
we need to make a sequel of it, and we need to come out with part 2, part 3.
Yeah.
Address
Yes,
the
because
queries
that is
which
not
we are
possible,
getting.
basically.
And I hope we can get our 2 panelists, and we can propagate the information which is much needed
you,
at
sir.
this point of time. Thank you.
Absolutely
thank
no
you.
issue, because Dr. Navarun Bhattacharya, who is the senior director for CDAC, he has promised as many times they will be extending their support, so we can make a complete sequel of these programs and we can take it forward. Absolutely no issues.
Thank you.
Sir,
Thank you
we
so
can
much.
start also our program at 4 o'clock or somehow, so
Yes.
that the time frame can be actually managed properly.
Yes.
Because
Sir,
late
we'll-
night, there's a problems of travel.
we'll look into this, sir.
Yeah,
Yes,
sir.
sir.
Thank
We
you very
will-
much.
we will-
Okay, with
we
these
will
things,
note
I
this.
think with the sincere thanks to all the participants, with our eminent panelists and all our eminent guests, we want to conclude it here with these things. So we say good evening and a good night to everyone.
Good night to
Thank
you.
you.
Yes,
Thank you, sir.
thank you, WBSC.
Thank you.
Thank you.
Thank you, sir.
Thank you, sir. I think Sudeep, I think if you are there, I think we can.
Yes, sir, I'm here, sir. So you can
So
end,
you can stop the recording and then you can end the session.
so you can end the session, sir. I stop the record. You can end the sessions.
Okay, I'm doing right away.